All right, welcome to another week of our online 1211 lab here in North Georgia. I'm Dr. Meyer, and this week what we're going to be taking a look at is our solutions lab. So we're going to be making a couple different solutions, and then we're actually going to use those solutions to do a precipitation reaction. And so we'll have kind of three main parts to this experiment, because we're going to make solutions two different ways. The first way that'll be kind of doing a full walkthrough here in just a second is going to be using a solid. So we have calcium chloride dihydrate, which is one of our reactants for a precipitation reaction. And we're going to be massing out an exact amount of solid to be able to make our solution. And then in the second part, we're going to be making a solution by doing a dilution on sodium carbonate to get it to a proper concentration for the precipitation reaction itself, which is what we'll do then in the third part of our experiment, which is mix the two reactants, isolate our precipitate through a filtration, and then we can get a final mass of our product so that we can actually do some stoichiometry and percent yield calculations at the end for our post-lab assignment. Now, making our solutions, I'm going to start, like I said here, for the first part, making our solution from a solid. So we have our calcium chloride dihydrate, and if you've gone through your pre-lab assignment, it's walked you through the general steps to figure out how much of this compound we should need to make the proper concentration and volume of our solution. And our goal is to make a 100 milliliter solution that has a concentration of 0.100 mole. And so using this thing's molar mass, and that .2H2O does matter to the molar mass for the dihydrate part of it, we should need about 1.47 grams of that calcium chloride dihydrate. So that's the first thing I'm going to go ahead and do, is actually go ahead and just mass out my sample. So I'm going to get a piece of whey paper, maybe, to mass this out onto. Zero everything here for a second. And now I'm going to go ahead and mass out about 1.47 grams. And unlike some labs where the amount of your particular reagent you're starting with doesn't usually matter as long as it's somewhere close and you record it, this we actually do want to be very, very precise. So you want this as close to 1.47 grams as we can possibly get it. And I'm going to try really hard not to go over that because it's much easier to add little tiny bits than it is to try and take some off. So it's still only right about 1 gram now, still a little less than a gram. So I'm going to add a little bit more. Actually very close. And that's actually extremely close. Actually, probably going to just leave it right there. So we have 1.469 grams is what I see on our balance right now. So 1.469, it's very, very close to 1.47 grams. So that's what I'm going to leave things at. I'll record that number here real quick so we have it for later. So very close to 1.47 grams we want to make the correct concentration. And now the next thing I want to do is I want to take all of that solid and I want to add it to my volumetric flask. So what I have here, this volumetric flask, I'm going to show this up kind of zoomed in real quick. Volumetric flasks are specific flasks that have actual markings on their necks that if you fill the liquid level exactly to that line, you are going to get the exact concentration that you want. And so our goal now is to be able to add all of our solid to our volumetric flask, but we're not going to immediately fill it up to that line. We're going to fill it up maybe to the start of the neck part, but then we're going to mix everything up and get our solution nice and dissolved, and very thoroughly and evenly mixed all the way throughout, and then we'll go ahead and fill the liquid level. Because it is possible when you dissolve a solid in a liquid that sometimes the volume of that solution can be altered a little bit. And so that's what we're going to actually come take into account by not filling it all the way to that line immediately. We'll fill it, add our solid here, fill our liquid over here, or up to maybe, like I said, the start of the neck. Then we'll mix it all up really good. Then we'll add the last little bit of water to get exactly that right volume that we want for the volumetric flask. All right, so for adding our solid, a couple things here that we can do. If you want, you can get a funnel to add all of your solid to your volumetric. If you're used to using whey paper and things like this a lot of times if you kind of fold it over, and actually fold it over a lot, you can kind of stick the actual entire whey paper into the volumetric top itself. In this case, looks like everything is mostly out of here. I have a little bit that I'm going to kind of get the last little tip in there so that I can flick out the last little bits that are stuck on the whey paper. And this gets the last of my solid into my flask. And so I shouldn't really have doesn't look like I have any solid left on my whey paper that I started with. And now my goal is I want to dissolve all this in water, right, and mix everything up. So in order to do that, I'm going to go ahead, this is distilled water or deionized water that we have available here in our lab. This is not just out of a tap faucet. For a precipitation reaction in particular, you really want to avoid just tap water from a normal sink because there's usually a lot of ions mixed in that can potentially cause unwanted precipitation reactions to occur. And so this is deionized water, and if you're in lab, in any of our labs, our squirt bottles are always filled up with deionized water that you can use as well. So that's what we're going to be adding here. And again, I'm not going to fill this all the way up to the line right away. I basically just want to fill this maybe to the start of the neck in terms of the liquid level. And then I'm going to mix everything up real good. So I'm just kind of slowly adding, just kind of keep an eye on where the water level's at. Right? And now what I'm going to do is I'm going to take and I'm going to mix this up. And so I have a ground glass joint is what it's called, where basically this fits in and makes a really nice tight seal at the top. I'm going to shake this up a little bit, but I'm not just going to constantly shake it up. I'm also going to vent, which means I'm going to take the little top and I'm going to open it just to the air, just in case any pressure builds up inside as I mix everything. This way I can open it up so that pressure can be released. Because sometimes what can happen if you take all your contents and put it in a closed flask like this and seal it and shake it up a lot, if pressure builds up, it might blow the top off, and if you happen to be holding it upside down and it blows the top off, you just spill your stuff all over yourself and everywhere on the counter. So that's what we're just trying to avoid. So mix it up, usually invert it a good few times, and then I'll go ahead and vent it, and I just kind of repeat that process a few times until I get all of my solution nicely, thoroughly mixed. You can shake it, but usually it's just kind of the process of inverting back and forth a lot and venting. And once I get this thoroughly mixed, the next thing I'm going to do is then take a little bit of water, the last little bit of water, to try and fill to the exact line in my volumetric. So I'm going to let this sit for a second and let some of the water kind of drip down along the neck itself. And the last little bit, to get this pretty accurate, I'm actually going to go grab, that I meant to grab already, a little pipette that I can actually use to very slowly just add the water, hopefully up to exactly that line. You can use a squirt bottle if you want to be really accurate. Actually, I can probably do this with a squirt bottle here. If I have one that's thin enough, this one looks like it should hopefully work for that. And so if I add in water, I can very slowly add the water. The squirt bottle is actually pretty good at adding it slowly. And now you see the liquid level starting to get up close to that line. Right? So now I want to very, very slowly add the last little bits of water until I get that liquid level pretty much right up to that line. I'm getting very, very close to it now. In fact, if I'm looking at dead on eye level, it looks like my liquid level is pretty much straight at where that line is for the volumetric. So liquid level is pretty much spot on here. So I now have a 100 milliliter solution that has almost the exact mass that I wanted. So this concentration should be very, very close to that 0.100 molar that we were aiming for. So that's how I've now made my solution from a solid. Now what we're going to go through and do is take a look at how do we get our solution prepared from a starting what we call stock solution in our next part, so that we can then do our precipitation reaction. All right, so for the second part of this experiment, now we're going to be making our second solution, this time for the sodium carbonate, by doing a dilution. So the way dilutions work is you're always going to have some starting stock solution, which is this really large bottle here that's 1 molar sodium carbonate. And our goal is we want a sodium carbonate solution that's going to be 0.2 molar, and we want it to have a volume of 100 milliliters similar to our first solution. So we can again use a 100 milliliter volumetric flask to make our solution, but we have to understand how dilutions work to be able to do that. And from a calculational sense, dilutions are pretty much, if you ever hear that word, you almost always think of like M1V1 equals M2V2 from like a calculation sense. Because the biggest thing about a solution, your moles of the actual solute, the compound you're interested in that's dissolved, don't change. You're only changing the amount of solvent that's there. And you're always going to start at a higher concentration and go to a lower one. So if our initial concentration is 1 molar, we know we want a final concentration of 0.2, so it's decreased by a factor of 5. That means that if we want a 100 milliliter total volume at the end, that 100 milliliters at the end times that 0.2 molar should be equal to our 1 molar times whatever volume of that starting solution we should need to do our dilution. And again, the pre-lab kind of walks you through that calculation to try and figure out how much of our starting stock solution we're going to need to begin with. And it turns out we should need about 20 milliliters of our starting stock solution. And then we're going to dilute that to 100 milliliters total, is how that process works. So I have our stock solution poured out here in a small beaker. I don't know if you can quite read the red marker labels, but anytime you pour contents of a larger kind of stock solution of this sort into a small beaker, always label that beaker so that you know what exactly is in there. Some people might think it's water, and then if they use it for something and it's not water, they're going to be in for an unpleasant surprise from either just a reaction standpoint or maybe even a safety standpoint. So always good habits. Label everything when you're going to take stuff out of a container. And so this is my starting sodium carbonate solution, and I know we just said we need 20 milliliters of it. So I have a graduated cylinder here. This is a 50 milliliter graduated cylinder, and what I'm going to do is I'm going to measure out just 20 milliliters of my sodium carbonate stock solution. And it's important to use a graduated cylinder for something like this because beakers are not very accurate in terms of their measurements. Like this beaker does have a line on it for 20 milliliters. That line is not accurate at all in terms of the number of significant digits that we would want. So that's why I'm using a graduated cylinder for this. And that should be pretty close to spot on 20 milliliters now in my graduated cylinder. And so I'm going to go ahead and add that stock solution now to my volumetric flask. And if you're really careful with this, you probably don't need the volumetric flask for this particular portion of making our solution. You could measure out now really accurately exactly 80 milliliters of deionized water to add to get to that 100 milliliters total. But volumetric flask, usually kind of the more accurate, kind of safer way of prepping these solutions. So now what I want to do, similar to what I did when I made my first solution, I'm not going to fill everything all the way to the line right away. I'll fill it up, again, probably to maybe like the start of the neck. And so my deionized water, that's what I have in this beaker, and that's what's next to my squirt bottle here of the water. I'm going to add this to the start of the neck on my volumetric. Then I'm just going to mix everything up good again to make sure I have my solution nice and thoroughly mixed. And then I'll add the last little bit of water I need to get the right volume of everything. And it might seem like this is kind of overkill on how you're prepping your solution, but these good habits do pay off, particularly as you get into reactions that are a little more particular, or things you have to be really accurate on, especially if you have very small concentrations. Taking these little extra steps really does matter. So I'm going to go ahead and invert this a few times, vent kind of like we talked about before. Do the same probably a couple more times here. And then what I'll do is I'll fill up this liquid level to the very last little bit as far as that marking on the neck of this volumetric. And then we'll have our two solutions prepped and ready to go. All right, so should be good and nice, thoroughly mixed. There's nothing to dissolve this time, so the solution should mix quite a bit faster. And now I'm just going to take my deionized water again from my squirt bottle. I'm just going to slowly add water until I get my solution all the way up exactly to that line. So we'll slow down here and just very slowly add the last little bits. And now I have my solution, my meniscus sitting pretty much exactly on my line for my volumetric. So I now have both of my solutions prepped and ready to go. I have my solid calcium chloride that I dissolved. I have my stock sodium carbonate that I've now diluted to the right concentration and volume. And now we should be ready to go to actually do our precipitation reaction, which will be the next part. All right, so for the third part of this experiment, now we're actually going to do the precipitation reaction itself. We have both of our starting reagents ready and prepped. We made their solutions. They're the right concentrations. So now we're ready to go ahead and mix these things. I'm just going to mix them in a beaker. You could do it in an Erlenmeyer or a beaker. It doesn't really make much of a difference what you exactly mix them in. It also doesn't really matter the order or how you start out mixing these two things. I could take, and you see I have a label, I could have my calcium chloride and add all of it first, and then I'll add all of the sodium carbonate, or vice versa, or I could just pour them in together. Isn't really going to make much of a difference in terms of making the precipitation reaction work. Most precipitation reactions work very effectively. It's not very difficult to get the reaction to occur. So the order of kind of how we mix things, not all that important. So I'm going to go ahead and add all of my calcium chloride in this case first. But again, that order not very important to the actual reaction itself. So I'll add all of its contents, and then next I'm going to do the same thing for my sodium carbonate solution. I'm going to add all of it, and immediately upon me starting to add these things, you already see the precipitate form. Right? My solution is now very cloudy and white, and I'm going to mix this up really good here just with the stirring rod, just to get as much of the reaction to happen as I possibly can. But the fact that you can already see how cloudy white that solution became instantly upon adding that sodium carbonate, that's pretty typical for most precipitation reactions. They do tend to happen very quickly, and they tend to happen very efficiently in terms of the amount of product that's often made. That doesn't mean you should expect 100% yield all the time. That's not very reasonable, but it does kind of give you an idea. You should expect to make a good amount of product fairly quickly for these precipitation reactions when they're happening. When you get on to 1212, you talk a little bit more about something called equilibrium, and then you can get a little bit more into exactly how much product and stuff to maybe expect for some of those things as well. But for right now, looks like that's pretty much it for a precipitation reaction. We don't really have a whole lot of other mixing or anything else to really do. Even if I stand here and stir it for another 10 minutes, I'm probably not going to get much more product to come out of this. So the next part of what I'm going to do is I want to be able to isolate all of this solid. And so for me to be able to isolate all of this solid, how I'm going to actually go ahead and do that is I'm going to do a filtration. Only instead of doing the gravity filtration that we did a couple weeks ago for the separation of a mixture experiment, this time we're going to do something called a vacuum filtration. It's just a little bit more efficient and kind of faster way of filtering and in particular in this case if we're trying to dry something also as we do it. And so what I'm going to do, I have a pre-weighed piece of filter paper. It's a much smaller piece of filter paper than what we had used the last time we did a filtration. And that's because this filter paper is going to fit exactly into my funnel here that I'm going to do my filtration in. And so I pretty much exactly fit my filter paper down in my funnel. Now, like I did for the previous time I did a filtration, I'm going to wet this just a little bit so that it makes a nice seal between the filter paper and the funnel itself. So I'm going to add just a tiny bit of water to this so that the sides of the filter paper are kind of sealed down nicely. Because all of that water hopefully is going to come through, and we're going to dry it off here when we're done in an oven anyway. So that adding a little bit of water that's not part of our solution shouldn't affect anything for our filtration. Now, the next piece of this for my vacuum filtration, you're going to notice I have a little rubber adapter here. This is so that I get a good airtight seal between my funnel itself and this actual kind of sidearm flask that I have hooked up to a vacuum pump. And what I'm going to do, I'm going to go ahead and turn this vacuum pump on. You can probably hear the hiss, and you're going to see a little bit of water that I poured through on the filter paper initially to kind of wet it and make a nice seal. Already start to get pulled through, and you can check how much vacuum it's pulling. I'm putting my hand over and see if you can hear the suction pop when I try to pull my hand off. It actually takes a little bit of effort to pull it off. So it's good. We have a good vacuum seal here. And now what we want to do is we want to go ahead and start filtering our product. And this can be nice and mixed up before we add it. That's a good thing. All right, sorry for the cut there. I had to make sure I had the right funnel kind of set up here and ready to go. So what we're going to do for our filtration step here, we're not going to do the gravity filtration the same way that we had done previously that we kind of showed in the mixture lab a couple weeks ago. In that one, we basically just kind of set up a funnel with a piece of filter paper in it and just kind of slowly let things drip through with gravity pulling it all through. We want things to go a little bit faster this time, and because we want to dry our final product, we're going to use something called vacuum filtration for this particular experiment. And so how that's going to work, setup's going to be very similar. I still have a piece of filter paper. I've pre-masked this, so I do know this thing's mass. That is going to be important to be able to figure out how much product I'm going to make. This thing's mass is 0.928 grams. You can write that down, or I'll show kind of all the data on a piece of paper here at the end as well again. And what I'm going to do, same thing kind of similar to what I did for our mixture lab. I am going to go ahead and still fold this over a couple times so that it fits well in my funnel here. And go ahead and open this thing. And then I can go ahead and add it to my funnel. And I'm going to squirt in some water to help make a good seal so that my filter paper stays kind of attached to the walls of the funnel. And you're going to see some water kind of slowly drip through. And the thing that's different here is notice I have my funnel attached to, this is a rubber adapter, so it'll make a nice vacuum seal when I turn on my vacuum pump. And then I have this kind of sidearm Erlenmeyer flask that's attached to my vacuum pump. So when I turn on this vacuum, it's going to be pulling air through here, which is basically going to pull any contents through my funnel faster. But it also will help dry anything in that contents a little bit faster as well, which is something we are interested in for our final product to get a mass for. So I'm going to go ahead and turn on my vacuum for my pump. And if I put my hand over it, you can hear actually a little bit of the suction that's actually going to happen if I do it properly. Like there you heard how hard it was for me to actually pull my hand out. So I'm pulling a good amount of strong vacuum here. That's good. That means this thing will filter very quickly. And what I'm going to do is I'm just going to go ahead and kind of constantly add my solution. And hopefully what we should see is that what's coming through in the bottom should be mostly clear. It's possible that the filter paper we have isn't going to catch all of our particulate that we formed in our precipitation reaction. But we should see a good amount of solid product getting left behind on the filter paper. And as I do this, notice I'm taking care that my solution as I add it doesn't go above where my filter paper is inside the funnel. I'm just trying to make sure that none of my solution just kind of escapes down through without actually being filtered properly first. Because I want all of the solution to pass through the filter paper, because that filter paper hopefully will let all the water pass through, but collect all of the solid. That's what we're really trying to do here. So I'm going to continue to add my solution. You see it just keeps kind of pulling the liquid through. It's slowing down a little bit. This is pretty normal because I'm starting to get a good bit of solid that's building up now actually on the bottom of my filter paper. And so it's going to take a little bit for this last or for all of this to actually get pulled through, even with a vacuum pump. If this was gravity filtration, I have so much solid product I'm going to be trying to isolate here that all of that solid kind of building up at the bottom of the filter paper make it take forever for the liquid to drip through. And that's really the purpose of the vacuum pump here in particular, as well as just helping to kind of dry things. Now, there are other funnel setups that are a little bit probably nicer for some of this. You can use Buchner funnels, which are kind of, instead of kind of a cone shape like this, they're almost more like a half a cylinder. Those will fit in here fairly well also, and they're pretty good at kind of pulling things through and also drying compounds. Problem is we didn't have any filter paper that would actually catch this particular solid because the particulate size is pretty small and would fit some of our beaker funnel, so I'm kind of making do with what we have here for our funnel and filter paper availability. So it looks like most of my liquid's drained through, so I'm going to keep adding. You can kind of hear it still pulling on everything. And what I'm going to do, I'm going to kind of cut the video here for a second, and I'll kind of come back to it here as we get towards the end and give you guys kind of a zoomed in picture from above of what's going on as I get to the very end, and you can actually see the solid that's building up in the filter paper itself. All right, so I try to give an overhead view here of as I'm filtering this compound, just so you can kind of see what's going on in my funnel. You can kind of hear that sound. That can sound really loudly now, probably too. And so what you're seeing here is I've adding liquid. I'm keeping it still within the filter paper so that all the liquid has to travel through it. And if you can see the bottom of the solution, it's still for the most part clear. There is some whiteness to it now, so there probably is a little bit of our solid that's not getting filtered out. That's okay. It's not really the end of the world here. If you were trying to be really, really accurate and get the best possible yield, we could probably do an extra filtration or two to make sure we get all of the solid out or get better filter paper. And if you want to talk about that, and I think there's some post-lab questions that may touch on some of those things in terms of like why you might not get 100% yield, this would be a good one to be able to talk about during the filtration step. But I'm just going to kind of constantly keep my solution filtering. And eventually, I'll have, once I've gotten through all of my liquid, I'll have just my solid left in the filter paper. And we get close to that, I'll kind of start this clip back up and show you what it looks like here at the very end. And then we'll look at drying it and getting our final mass. All right, so as this filtration continues, I want to kind of just point out some other things, good habits as you're doing filtrations. As I'm getting to the end of this, you notice there was a lot of, until I just swirled this solution, there's kind of a lot of particulate kind of like settled to the bottom. And so what I'm doing here is I'm just kind of mixing it up really good so that when I pour this, hopefully all the solid comes out as I pour it into my filtration setup. So that way I'm making sure I'm hopefully getting all of my solid, and I'm not leaving a bunch of it stuck in my, you can actually see a lot of the solid still stuck in here, right? So what I'm going to do to get this last little bit out, you can take a little bit of, ideally either room temperature or even a little bit chilled in an ice bath. You can take this and actually chill it in an ice bath, water. And I'm just going to kind of squirt this through the sides and the edges, trying to get out and have enough liquid there for all of that solid that's still in here as product, so that it can stay in the solution or just be suspended in the solution, so that it's easier for me to pour it all out so that it can get collected. I'll do this probably once with this little rinse that you just saw me do, and then what I'll do is also, once it's all empty and most of this is drained, I'll probably just do a rinse through the beaker while holding the beaker over this so I can collect all of basically the kind of anything else that might be on the sides that I can rinse out. And that way I get hopefully all of my product out of my starting container where I did my reaction, and hopefully all my product onto the filter paper where I can collect it and mass it here at the end. So almost to that point, I'm going to go ahead and actually add this little bit. I'm going to stir it good so I get all of it, hopefully. Add that. I'm going to let that go down a little bit more. It's up pretty close to the top of the filter paper right now. And then I'll do kind of what I described as far as kind of holding this here above my filter paper while kind of squirting it with the water, trying to get all the last contents out and into my filtration setup. So we're very, very close to being done. As soon as we get this part done, the only last part is basically going to take the filter paper out. We're going to put it on a watch glass. The reason we're going to do that is just going to be easier for us to dry it, because we're going to take that watch glass and go put it in an oven. And that way we can dry our sample for about 10 to 15 minutes. So any water that's left, both on the filter paper or just in our sample itself, we can hopefully get that water out and removed. So then we can come back and take a final mass of our hopefully mostly dry product. Right, so our liquid level is getting pretty close down to the bottom now. So what I'm going to do here with the last bit of my beaker, I'm going to kind of squirt my stirring rod and kind of the contents of my beaker to try and make sure I get any last bit of my product into my filtration setup. And that way my beaker now should be pretty clear. Shouldn't have a lot of kind of like dust kind of still sitting in it that's like white color, because that's probably product. There might be a tiny, tiny bit still left. For the most part, it looks like I got all of it. And so now it's just a waiting game. I'm going to let this finish drying. So I'm going to cut this here for a second. I'll show kind of how I go about removing the filter paper, getting it kind of spread out on my watch glass, and then I'm going to go ahead and dry it. I'll show you kind of the dried product and the final mass in a final clip. All right, so the filtration's pretty much done at this point. You can see that we've collected a bunch of white powder here at the bottom of our filter paper. There's no more liquid that's really kind of coming through anymore, so we've kind of dried it as good as we're probably gonna get off the vacuum pump. So I'm gonna go ahead and shut the vacuum pump off at this point. And then what I'm gonna go ahead and do, I'm gonna go ahead and break my seal. You should hear a little bit of a pop sound. There you can hear the hiss as the vacuum seal breaks. And now I can go ahead and remove my filter paper. I'm gonna go ahead and basically just move it to a watch glass and kind of spread things out here. You can see all of our white powder here that's kind of all collected. And what I'm gonna do now is I'm gonna take basically our sample and I'm just gonna go put it in an oven for probably about 15 minutes, maybe a little less, maybe 10 to 15, and just let it dry. And after that 10 to 15 minutes, hopefully all of the water that's still stuck either in our sample or in the filter paper itself will have a chance to evaporate because the oven's a little over 100 degrees Celsius. We get the water to evaporate but not decompose our final compound here. And then we can hopefully get a mass of this that'll give us a reasonably accurate final mass for how much product we've isolated here. All right, so I've had a chance to let our product dry in an oven for a little bit and go ahead and take a mass of it. So you can see our mass given up here, the 1.831 grams. It's our final mass of our whey paper, our filter paper and the product. And so you can take the difference then of the filter paper by itself and then the filter paper with the product to find your product mass. Looks like it's a little bit above 0.9 grams, which should be a decent yield. It's not going to be 100%, but I mean, like I said, it's almost never going to be the case for these reactions. There's a number of reasons for that in terms of things that can go wrong or places we can lose product. One of the biggest ones is usually in that filtration step. Right, we mentioned that probably some of that product slipped through the filter paper. We could see a little bit of white color to that filtration kind of filtrate at the bottom. So we probably lost a little bit of product there. And it's also just rare for reactions to go all the way to 100% completion to begin with. So I think the percent yield when you calculate it should still be pretty good. And the last other thing I want to kind of show here, just the product itself. It's kind of this nice chalky white powder. Now that it's dry, if I kind of shake it around, it'll kind of move around pretty easily. You can tell it's dry. And really, if we're talking about like calcium carbonate, that kind of really is almost what it is. It's kind of it's something in terms of getting rid of and disposing. We could throw it right just in the trash. We don't need any special waste disposal for this particular experiment, which is one nice thing about doing it this way. All of our components are not really toxic to the environment. We do want to watch calcium concentrations in normal tap water and control them if we can, but we don't have enough here really to worry too much as far as the solutions that we have as far as leftover calcium. So most of that we can put down the sink. This waste can go in the trash. So pretty easy cleanup for this particular experiment. And that pretty much should wrap up all the details kind of that you need. And really, like I said, the measurements and things that you need for this particular experiment aren't very many. It's really just the mass of that filter paper and the filter paper and product. Everything else is basically calculations from that. I did record the mass there that we use for calcium chloride at the start. That number I don't think is asked for by CSC Pub at any point, but it's just there as reference. We wanted 1.47 grams, so 1.469, very, very close. So all of our concentrations and all of our measurements should be pretty accurate throughout. And so hopefully then the rest is just calculations. Like I said, hopefully the number should make some pretty good sense as you're going through. If you're in any issues, please make sure to contact us, let us know, let your instructor know. We'll be happy to help, and we'll see you next time.